Hello everyone, this is our session 8 on matrices. We are moving on to application of matrices. So let us start. Now application of matrices is in solving of linear equations with 2 or 3 variables. So we know linear equations in 2 variables. For example, we have x plus 2y is equal to 8 to 6x plus 5y is equal to 9. So with the help of matrices, we can solve these equations. Okay, so let us begin as to how do we do that. I'll take a general example of a sum of two linear equations, and I'll show you how we can write the matrices, or you can say the matrix form of linear equations. Okay, so let us begin. First example, we have 2x plus 3y is equal to 5. Okay, and we have x minus 4y is equal to 9. Now these are two linear equations. Normally we use simultaneous equation methods, elimination, or by multiplying 1 with 2 and then subtracting it. Okay, so now we are going to use matrices. So how do we write it in matrix form? Let's say I'm writing this as 2x plus 3y, okay, and x minus 4y, okay, is equal to 5 and 9. That means what I have done, on the left side I have a column matrix, on the right side also I have a column matrix. So by equality of matrices, I am still in the same form, that is the equation form. Now what I'm going to do is separate the variables from this. That means only write the matrix of coefficients, okay, over here. Then I'll put the matrix of variables, okay, and the matrix of constants. Okay, so the first one has become the matrix of coefficients. Let us call this as the matrix A. The second one has become the matrix of variables X, and the last one has become the matrix of constants, so we call it P. Okay, so we have an equation AX is equal to B. Now we've come across this equation in the previous miscellaneous exercise, right? Find the value of x if a and b are given. That is exactly what we have to do over here. So what we have to remember is multiplying both sides by a inverse, okay, is equal to b. Is equal to a inverse b. A inverse a is ix is equal to a inverse b, and x is equal to a inverse b. So this is one method of finding the value of x. Now what is x over here again? It is the matrix of variables x and y, right? And a inverse we will find out, and b is the matrix of constants 5 and 9. Okay, so when you will multiply the matrix A inverse with the matrix B, we directly get the values of x and y. This is called as method of inversion to find the variables. Okay, with the help of matrices, it is called as method of inversion. So we can name this as method of inversion. Okay, inversion means find the inverse of matrix A. Okay, method of inversion. Now one thing we need to remember is this, I have written matrix of 2 variables. You can do the same thing for 3 variables. That is, let's say for example, I have 2x plus y plus z is equal to 5. 3x plus 2y plus z is equal to 9. X plus 2y minus z is equal to, say, 8. Okay, so see, we can make a matrix of coefficients for the same, a matrix of variables, and a matrix of constants. Observe this carefully. The first matrix will be of the coefficients. So we write the coefficients with the sign 2, 1, 1. Coefficient of x, coefficient of y, and coefficient of z. Again, coefficient of x under that 3, then 2, and then 1. Last one, 1, 2, and minus 1. Okay, write the coefficients with their signs. Text is x, y, and the third variable z. And the last one is matrix of constants 5, 9, and 8. Okay, now we have 8 here. Okay, now observe the orders of the matrices. That is, the first one is a 3 by 3 matrix. The second one is a 3 by 1 matrix. That is the column matrix. So 3 rows and 1 column. Again 3 by 1 matrix. By multiplication rule, what should the answer matrix be? What should the order be? It should be the row of the first matrix, that is over here, right? Row of the first matrix and column of the second matrix, so which is 2. So it does follow the rules of multiplication also. Similarly, you can check this over here in this matrix over here. This is a 2 by 2 matrix. This is a 2 by 1 matrix, and this is also a 2 by 1 matrix. So we have row of the first matrix is row of your answer matrix, and column of the second matrix is the column of your answer matrix, right? So yes, it does follow the rules of multiplication. Okay, we've done, I just explained you one method to find out x, y, or the variable matrix, that is method of inversion. Now the next method is called method of reduction. Now what is this method of reduction? Method of reduction means we have to reduce the matrix, okay, A matrix. We have AX equal to B, right? A is your matrix of coefficients, X is your matrix of variables, and B is your matrix of constants. So what do you do with matrix A? You have to reduce it to one, either an upper triangular matrix, okay? Now what do you understand by upper triangular matrix? All the elements below the diagonal are 0, okay? Sorry. Upper triangular matrix. You can just, for example, put it in a 2 by 2 matrix, so 1, 2, 1, and 0. So below the diagonal, the elements are 0. Second, lower triangular matrix is just an example to show you. This over here is an example. Okay, lower triangular matrix. Okay, that will be then 1, 1, 2, and 0 over here. So all the elements above the diagonal are 0. Third one, you could convert it into a diagonal matrix. Now, what is a diagonal matrix? All the elements in the diagonal are constant or are same, and the others are 0. Or you can call it a unity matrix. If you get a unitary matrix, you directly get the values of the variables. But sometimes you will get a diagonal matrix. So diagonal matrix means all the elements in the diagonal are there. Could be same, could not be same, but all the remaining elements are 0. Okay, so that is a diagonal matrix. Now, why do we have to do this? So, for example, I'll just take this matrix 1, 2, 0, 1. Okay, 1, 2, 0, 1. I've converted a given matrix into a lower upper triangular matrix. Okay, 4 and say 6. Okay, so now let us perform the multiplication of the matrices on the left hand side. So we have x plus 2y is equal to 4. Second one will be y is equal to 6 because 0 into x is 0. Now, if you observe, I've already got the value of y. I'll use this value substituted in the equation above. So x plus 2 into 6 is equal to 4. 2 6 are 12. So x is equal to 4 minus 12, that is minus 8. So we get both the values of x and y. What is the method of reduction? Just to reduce the linear equations in simpler format and then use elimination rule to find out the variables. So one answer will be direct, the other has to be substituted in the equation and you have to find out. Similarly, you will work with a 3 by 3 matrix. So when it comes to a 3 by 3 matrix, one variable will be directly given, that is after you convert it into an upper or a lower triangular matrix, and then the remaining two you have to resubstitute the values and get the answer. Okay, so when we'll solve the problem, it will become simpler to understand. Only remember, method of reduction, format of your linear equations remains the same, ax equal to b. Okay. We will not change the order. If you do that, then what happens is the order of the matrix will change, and that will change the answer matrix. So first is the matrix of coefficients, then matrix of variables, and then matrix of constants. Then there are two methods of solving: method of inversion, method of reduction. Inversion is to find A inverse, multiply it with B, that gives you the matrix of variables directly. By equality of matrices, you get X and Y. Second is method of reduction. In method of reduction, what happens? Method of reduction, you reduce the matrices into either of these forms, which are that upper triangular, lower triangular, and diagonal matrix. Okay, so any one of these we'll use, and we'll convert it, and then we'll find the answers for X and Y. Okay, so I am beginning with exercise 2.3 over here. So first one, question 1 says, convert the following equations, find the values of X and Y by inverse method. So we are going to use the inverse method. Question 1, I'm doing the second one. Okay, first one is simpler. I just solved one of them. So X plus Y is equal to 4. And your second equation is 2x minus y is equal to 5. Okay, so what we have to do is convert them into matrix. So A is equal to your matrix of coefficients 1, 1, 2, and minus 1, right? And X is equal to your matrix of variables, and B is equal to your matrix of constants 4 and 5. First one and then the next one. Okay, this is B. Now, if how will we start the sum? We'll say AX is equal to B. Okay, so for once, let's substitute them, and then we will use the inverse method. X, Y is equal to B. That is 4 and 5. Okay, this is the form you have to get it in. Now, what do? We'll use the inverse method. So inverse method is A inverse A X is equal to A inverse B. Okay, A inverse A is I. So Ix is equal to A inverse B, and X is equal to A inverse B. You have to write this every time you do by the inverse method. Okay, now let us find the inverse. So how do we find the inverse? Very simple. Let's take the matrix A. Okay. Yeah. So matrix A is 1, 1, 2, and minus 1. 1, 1, 2, and minus 1. We require matrix of cofactors. So matrix of cofactors, right? So what will that be? I'll do it directly now. Matrix of cofactors, the first element remains as the minor itself. So first element is your minor. Then the second element will be with a minus sign. The third element will also be with a minus sign. And the fourth element will be without the sign change. So this will be your matrix of cofactors. What will be adjoint of A? Adjoint of A is transpose of this matrix. So minus 1, minus 2, minus 1, and 1. Also, find the determinant of A. What is determinant of A? Minus 1, minus 2, that is minus 3. Okay. Therefore, A inverse is equal to, A inverse is 1 upon determinant of A multiplied by adjoint of A. Right? So this will be 1 upon minus 3 multiplied by what is our adjoint? It is minus 1, minus 1, minus 2, and 1. This is our adjoint. Okay, I'll just put the minus sign inside. So we'll have 1 upon 3 outside, 1, 1, 2, and minus 1. Okay, this is your A inverse. How do you find X then? X is equal to A inverse into B. So that is, what is A inverse? 1 upon 3, right? 1, 1, 2, and minus 1 multiplied by B. What is the value of B? It is 4 and 5. So we put 4 here and 5 here. Okay. Perform the matrices multiplication. Leave the 1 upon 3 outside. So we'll have 4 plus 5, that is 9. And the next one is 8 minus 5, that is 3, right? So the answer to this will be, we'll put 1 upon 3 inside now. So 3 and 1, right? Now the last step will be, we'll put x as your matrix x comma y, right? And your answers as 3 and 1. Here you have to write by equality of matrices. Okay. We have to mention this. X is equal to 3 and y is equal to 1. So our solution set can be given as x comma y is equal to 3 comma 1. Okay, this could be a solution set of the two linear equations that they have given us. Okay, I'm doing one more sum from this one. It is the third one. Okay, now the third one, the equation is 2x plus 6y is equal to 8 and x plus 3y is equal to 5. Okay, what you have to do is write your matrix form of the linear equations and your constants. Now, one step we did not do in the previous matrix, okay, to find the determinant first and check whether the A inverse exists. That is a rule for A inverse, that if it exists, only then go ahead with the matrix of cofactors. So here, luckily it did exist and we got a solution. But in this matrix, if you observe, what is the determinant of this first matrix? Let's check. This is A. So determinant of A will be 6 minus 6. So determinant of A is equal to 0. Then we can say that A inverse does not exist, first of all. Okay. So we cannot find it by inverse method. You cannot find it by reduction method either. Reason being, just observe the first equation. Divide this equation by 2. What are we getting? We are getting x plus 3y is equal to 8. Now, if you observe, the second equation is also x plus 3y. So there's an ambiguity in the question. Left hand side is same and right hand side is different, which cannot be possible, right? So this sum does not have an answer. You can say not. It is not possible to solve. Okay, let's go to question 2 now. Question 2 says find the values of x and y by using reduction method. So I'll do the second one here. Okay. Question 2, second one, x plus 3y is equal to 2. Okay, and we have 3x plus 5y is equal to 4. So what do we do? Again, ax is equal to b. So 1, 3, 3, 5, xy is equal to 2 and 4. Okay, therefore, ax is equal to b. Now what do we have to do? Reduce. By reduction method means to reduce the A matrix into an upper triangular or a lower triangular matrix. Okay, and then get the answers by elimination method. So first, let us substitute the, sorry, not substitute, it's already there. What we'll write is the first transformation. So what is the first transformation? I'll convert it into an upper triangular matrix. I'll convert 3 to 0. So I'll write R2 changes to R2 minus 3 R1. Okay. So which will be, first row remains as it is, 3 minus 3 is 0, 5 minus 9, 5 minus 9 minus 4. Okay. X, y as it is, and what will change is on the right hand side. So 2 as it is, 4 minus 6 minus 2, right? Now what do we have to do? We have to perform the multiplication of the matrices on the left hand side. So I'll just solve it here. It will be x plus 3y, x plus 3y is equal to 2, and the next one will be minus 4y is equal to minus 2. So y is equal to half. We'll put y equal to half in the first equation. Sorry. Okay, so y is equal to half in the first equation. X plus 3 into half is equal to 2. x is equal to 2 minus 3 by 2, 4 minus 3 by 2, that is half. So x and y both are half. So your solution set will be x comma y is equal to half comma half. Okay. This is your question 2. Let's go to question 3. Question 3 says, question 3 are word problems. First, we have to understand what is the word problem. So let me just read through the word problem. One second. Yeah. So the first one says, sorry, question 3 says, the cost of 4 pencils, 3 pens and 2 erasers is rupees 60. Cost of 2 pencils, 4 pens and 6 erasers is rupees 90. Whereas the cost of 6 pencils, 2 pens and 3 erasers is rupees 70. Find the cost of each item by using matrices. So the very first step would be let the cost of one pencil, one pen and one eraser be x, y and z respectively. Okay. So what we'll do is, so we'll say let the cost of one pencil, one pen and one eraser be x, y and z respectively. Please write this word, it's very important. What does x denote, what does y denote, and what does z denote? Or simply you could say cost of one pencil equal to x, cost of one pen equal to y, and cost of one eraser equal to z. Okay. The next thing would be to write the equations and then the matrix form. So your first equation will be, the sum says cost of 4 pencils, 3 pens and 2 erasers. 4 pencils, so 4x, 3 pens and 2 erasers is equal to rupees 60 is given to you, right? Then cost of 2 pencils, 4 pens and 6 erasers. So second equation will be 2 pencils, 4 pens and 6 erasers. So 4y plus 6z is equal to 90. Okay. And the last one, whereas the cost of 6 pencils, 2 pens and 3 erasers. 6, 2 and 3. So 6x plus 2y plus 3z is equal to 70. Find the cost of each they have said. So that means you have to find the value of x, y and z. Okay. I'll just write the matrix form over here. So matrix form will be to put all the variables in one, your x, y, z in the other, and the last one would be to put the constants. Okay. So let us start with variables. So we have 4, 3, 2. We have 2, 4 and 6, and then we have 6, 2 and 3. Next we have x, y and z, and then we have 60, 90 and 70. Yeah. So this is your matrix form. Now what they have asked you to do is find the value of x, y and z. We can go by two methods. You can either use your reduction method or you can use your inverse method. I have used the reduction method first, so I'll show you by the reduction method. You can try it with the inverse method as well. Okay, so let us start. I'll take the matrix again. It is 4, 3, 2, 2, 4, 6, 4, 3, 2, 2, 4, 6, and we have 6, 2 and 3. Okay, x, y, z, and we have your constant 60, 90 and 70. Okay, Now my first transformation would be, if you can observe the second row, you can divide that by 2. So I'll say R2 changes to R2 divided by 2. Okay, so we have 4, 3, 2 as it is, 1, 2 and 3, 6, 2 and 3. Okay, then we write x, y, z, and this will be 60, 45 and 70. You have to divide on the right hand side as well. Okay, then I'm going to swap the first and second row. So R2 swaps with R1. Okay, so 1, 2, 3, 4, 3, 2, and we have 6, 2 and 3, x, y, z. Okay, and we have swapping over here as well. So 45, 60 and 70. Okay, I'm going to convert this into a lower triangular matrix. So for that, I need the elements 4, 6 and 2 to become 0. I'll start with changing 4 to 0. So what do I write over here? R2 changes to R2 minus 4R1. Okay, so remember, second row is changing, first row remains as it is. So 4 minus 4, 0. 3 minus 8, that is minus 5. Okay, and 2 minus 12, that is minus 10. Okay, the third row remains as it is, 6, 2 and 3, x, y and z. Okay, and then we have our on the right hand side matrix. So right hand side will become, R2 is changing, so first row has to be remaining as it is, 45. 60 minus 4 times 45, so that is 4, 5 is 20. 60 minus 180 minus 120. Okay, and the last number as it is. Okay, now this has become 0. I'll make 6 0. How do we make 6 0? R3 changes to R3 minus 6R1. Okay, so 1, 2, 3 as it is, 0 minus 5 minus 10 as it is, 6 minus 6 has become 0, 2 minus 12 minus 10, and 3 minus 18 minus 15. Okay, yeah, then we have your xyz here, and the last one, what is changing? R3. So the first two rows remain as it is, 70 minus 6 times 45, so that will be 270 minus 70, so minus 200. Okay, now if only minus 10 remains to make it 0, right? So how will we make that 0? We'll say R3 changes to R3 minus 2 times R2. Minus 10 plus 10, we are going to make that 0. Okay, so let's write the answer matrix over here by doing the transformation. We have the first row as it is, 1, 2 and 3, second row as it is, right? And the third row is changing, so we made this as already 0. Next one is minus 10 minus of minus plus 10, so 0. And minus 15 plus 20, so 5. Okay, that is your matrix XYZ here. And here we have to change R3, the remaining are as it is. So 45 minus 120, and this will be minus 200 plus 240. So we are remaining with 40. Okay, so the answer, now what do you have to do? You have to write the equations again, that is multiply again. So we'll have x plus 2y plus 3z is equal to 45, first equation. Okay, then we have minus 5y minus 10y equal to minus 120. We'll just divide here with minus 5. So we get 5 plus 2y is equal to 5 4 5 2s are 10, 4s are 20. Yes, here 5 2s are 10 and 5 4s are 20, 24. So this becomes your second equation, y plus z over here. Sorry, it should be z. They look the same, 2 and z. Let me change that. We'll put this z here. Y plus 2z is equal to 24, right? This is your second equation. Third equation, 5z. Okay, I'll write it like this. 5z is equal to 40. That means z is equal to, so therefore z is equal to 8, right? Substituting in the above equations, what we'll get the values of x and y. Okay, so we'll get y is equal to 8 and x is equal to 5. Okay, so what is the final answer we have to write? Cost of one pencil is equal to rupees 5. One pen is equal to rupees 8 and one eraser is equal to rupees 8. Okay, because x is 5, y is 8 and z is also 8. Okay, when you substitute it, you get this answer. I hope I've made this sum clear. You can try it by the adjoint method also. You should get the same answers. Okay, I've just done the transformation so that we get used to the transformation method as well. Okay, the reduction method, I mean. Okay, if you have any doubt, do let me know. We'll go to the next two sums in the next session and also the miscellaneous exercise. Thank you very much.